Good evening. Today we are going to see the last part of the term work, that is column based. Now in column based actually we have three cases. We are dealing with case 3. If we will go to here playlist, and in that playlist case 1 is already considered. Now what are the three cases that you try to understand? Case 1 we have E less than 1 by 6. Means in this, if I will draw the column base, then my whole column base is under compression. So we are being like this. So this is case 1 in which your whole column base that is under compression, and then we have to find out if we have column over here, then we have to find out bending moment at this critical section by considering this part, and then we have to find thickness corresponding to this bending moment. Case 2, in case 2 actually we have base that is both in compression and tension, but my tension part is very small and hence that is neglected in case 2. We do not have problem on case 2 in this playlist also, so that I will put afterwards. Now what we have changed in case 2 that you try to understand. So we are being like this. So actually this portion it will go up, and then we have this as tensile, but this is very small portion, so we are going to neglect it, and we are going to consider this pressure distribution diagram, and we will find bending moment at this again, and then we are going to calculate the thickness. So in case 1 we have here some value P minimum, and that is we have throughout compression, and in case 2 we have zero value over here, and this value is x, which is less than the length of base plate. And in third case, if we will go to case 3, and in this case 3 your considerable portion that is under tension, and therefore we have to consider both tension as well as compression. We have somewhat like this, and therefore in case 3 we have to go for both compression and tension. Our project we have maximum case 2. Case 1 you can go to playlist, that is term work or design of steel structure, then you will come across this, and this yet I have not uploaded. Now I will go for this case 3. Now we have this problem ISHB at 925 Newton per meter. Column has to support factorial axial load 363.75. This is my reaction, that is gantry girder plus truss. So if you will go to connection, and that is eccentric connection, then you will come across these values, and this 102.51 kilonewton meter. The column is on concrete foundation, M25 grade of concrete. Now we have step 1, given data. We have this as P is equal to 363.75 kilonewton, and we have M is equal to 102.51 kilonewton meter. Then we have FCK 25 Newton per mm square. Then we have step 2 properties. Step 2 properties of section. And then we have ISHB as column. As a column. and then dimensions D we require, which is 450. BF we require 250, and TF we require 13.7 millimeter, and TW, that is actually we need not require TW, we require these values, so only 3. Then we have step 3. So dimensions of base plate. Dimensions of base plate. We have assumed, go little bit higher side for projections. So assume 150 mm projections beyond face of column. Therefore, L is equal to, we have 450 plus 150 plus 150. So we have this as 750 millimeters. And therefore, FCB, this already we know that we have this as FBR, and we have this value as 0.45 FCK. And we have this value 0.45 into 25, and this value comes 11.25 Newton per mm square. 11.25 Newton per mm square. Now this value, that is FBR, that is given in IS code. If you will go to the column base, and in that column base, this value that is for column base, that is given bearing strength clause number 7.4.1. So this is given clause number 7.4.1, page number 46. 46. From there we have this value. Then actually we have value E by L. E by L. E we have 300. So actually here we should have E, that is equal to 300 millimeter. This already we have. If we will go to problem of gantry girder, then we have this value of E as 300. So E we have 300, and L we have taken 750. And from this we will have this value that is equal to 0.4. And knowing this value 0.4, we have this as case number 3. Because we have seen we have 3 cases. So this is greater than 0.33. Because case 1 we have E by L less than 1 by 6. That is 0.167. Second, we have E by L greater than, this is less than or equal to greater than 1 by 6, less than or equal to L by 3, 1 by 3. So it goes to 0.33. And last we have E by L greater than 1 by 3. And now we have this value that is 0.4. Now we have actually derivation to calculate this value of x. Now we will not go to that derivation. I will directly write over here, that is x equal to L by 2 plus A plus minus root of L by 2 plus A whole square minus 2 in bracket M plus PA divided by FCB into B. And then we will calculate the values. Now we are going to consider 75 mm diameter, 75 millimeter as end distance. Now in case 3, we are going to provide bolts, and for that bolts, we are going to consider this distance as 75. Both sides we have these bolts. Anchor bolts we are going to say 75. So we have this as 75, and therefore value of A we are going to get equal to 350 minus 75. Now what is this A? Now you try to understand this A. So we have this as column. So we have this column. And A, that is the distance from the bolt center to the center of column. So this distance we have A. Now this we have 75. This we have 75 actually. And then this value, so we have 750 by 2. And then it comes 375. And then actually this is not 350. So this is 375 minus 75. So it comes 300 millimeters. Now we have L by 2 plus A. So L by 2 we have 375 plus A we have 300, and we will get this value, that is 675 millimeters. Now 2 in bracket M plus P into A divided by FCB into B. Now we have 2 in bracket M we have 102.51 into 10 raised to 6 plus 363.75 into 10 raised to 3, and the value of A we have 375, and divided by FCB we have 11.25, and B we have same dimension is considered, whatever we have, that is L. And this value we will get, just I will calculate it, 10 raised to 6 plus 363.75 to the power 3 into 375 multiply by 2 divided by 11.25 into 750. It comes 56.63. 56.63. So just I will check it. 102.51 to the power 6 plus 363.75 to the power 3 multiply by 375 multiply by 2 divided by 11.25 into 750, and then it comes 56.63 into 10 raised to 3. And then we will substitute this value, and we will get X, that is equal to 675 L by 2 plus A minus L by 2 plus A 675 square minus 56.63 into 10 raised to 3. And from this we will get value of X, that is equal to 675 square minus 56.63 to the power 3 root of this into minus 1 plus 675, and it comes 43.34 millimeters. Now from this we will get value of MC, that is equal to FCB into X into B into C minus X by 2. And we will get this value, that is 11.75 into 43.34 into 750 in bracket. We have 150 minus 43.34 upon 2. This 150 actually we have projection. That means my value of X is somewhere here. So this is X, 43.34, and we are taking moment about this. So this value is 11.25. So 11 point, we have this value 11.25, not 75. So 11.25. So 11.25 and into this X 43.34, width we have 750, and then we have distance from center to this. So this 150 minus half of this 43.34 by 2, and we will get this value, that is equal to 11.25 into 43.34 into 750 multiply by 150 minus 43.34 divided by 2, and we will have this value 46.93 into 10 raised to 6 Newton millimeters. And then we will equate it to mdz as usual, that is 1.2 ze Fy upon gamma mo, and that is equal to m. And then we have 1.2 into, now here we are considering B into T square into 250 upon 1.1, and moment we have 46.93 into 10 raised to 6. And from this I will get value of T, that is equal to, so we have multiply by 1.1 divided by 250 divided by 750 divided by 1.2, and the root of answer is, so 46.93 to the power 6 multiply by 1.1 divided by 250 divided by 750 divided by 1.2, then we have root of answer, it is coming wrong, 46.93 to the power 6 divided by 250 into 750 into 1.2 multiply by 1.1, and the root of answer 15.14. So check it, 15.14 millimeters. So, and then we have to provide it. Therefore, provide T, that is equal to 16 millimeters. Just check these calculations. 1.2, sorry, that ZE, we have BT square by 6, we have to take 6 over here. So therefore we have this square multiply by 6, and then root of this answer, and that comes 37.1. So 37.1, and therefore provide T equal to 40 millimeters. We have ZE, that is BD square by 6, and that 6 was remained actually, and therefore we are getting value less, and therefore provide base plate 750 mm by 750 mm by 40 mm. and then go last step, that is step 5. So we have T that is equal to FCB XB minus P, and we have this as 11.25 multiplied by 43.34 into 750. The value of this is 363.75 into 10 raised to 3. And this tension comes 11.25 into 43.34 into 750 minus 363.75 to the power 3. It comes 1.93 into 10 raised to 3 newtons. And it is very less, so we can directly say provide 2 bolts of 16 millimeter diameter. If it is not, if it is larger one, but if you will go with the rare cases, we will go larger one. And now we have to calculate this length, but here as it is coming very less, so provide 100 millimeter length below base plate. So this is all about this. So we have actually step 6 connection you can go, and we have connection same as we have in case 1. So I will not go to this. You can refer case 1 and then find length of weld or width of weld. So we will stop here only. Remaining part we will see in the next lecture. So thank you.